Today we're looking into textures. So that seems like something we really need. Unfortunately, it's also something that is not so intuitive. At least I personally don't find it too intuitive. So I hope, good morning to everyone again, and I hope you are awake and ready for texturing. Again, there are a lot of sources involved, of course, and you can look up everything. However, current times are basically happening on YouTube, so there are so many great people out there who create videos, who create tutorials, who make online courses. So you can also check online what's out there. So the main problem is that we might have a ball, and if you're wondering, this is really something. I have it here. This is the original ball from this photo, and if you're wondering why I have an orange ball, it's a black roll thing. It's something for workout. I mean, not really workout, but post-workout stuff. And this helped me through the pandemic because then I could do teleconferences and do something in between, like training strength for climbing or something like that. But this is already a really complex thing because if you take a look at it, a close look at it, it is round on one hand, but on the other hand, it has a very fine-grained texture. And if we just put in an orange sphere, like here, then this is basically not enough. This could be an orange, this could be this black roll fascial ball, but the color and the shape are actually not enough, although it's a straightforward camera. So what's the difference? The difference is actually the texture. If you touch it, it has a rough texture. And also the same thing is discussed, or is the same term is used for describing how to make this look more realistic. So in this case, we have this rough surface with the small notches. I intentionally did not show the seam and the logo. So the seam is somewhere, or you can see a little bit of the logo actually printed into it. And we could create the notches, but they typically have too many triangles. So if we take a look at that, that would be, hopefully resembles the ball with very bad lighting. So I didn't do much about the lighting, just as an example, but this has many more triangles than just the sphere. So that's kind of the problem. So the key idea is, instead of modeling the geometry and the perfect material, we define a function for each point on the surface. So that's the cool part. So if we have a surface and we make it flat, like I'm misusing the new stickers from A Webbing Journey. So if we have something like this, and then we say we want to have a picture on it, like this little spider, then we make it flat, and then we can define on this hand a point U by V, and then we say, okay, this is black, this is part of the eye, this is a black pixel. That is this function FUV, which gives us, for instance, a color on a surface. So the surface in 3D is flat, and the coordinates on the surface might be UV. I mean, you can specify the color, but you can also give the roughness or the specular component. You can say it's, in this case, reflective, it's opaque, it's brown, it's transparent, it's dirty. So you can basically define everything. That's the cool part about it. So what we do is basically we use an image to look it up. So textures are often, the term textures is often used for images too. That while it implies that this leads to color, you will see that images can also be used to transport non-color information. So that is something from computer vision. I'm not sure how much you know about computer vision, but there you typically have non-seen information in pictures too. Like if you check the satellite images from Landsat, These are all wrong colors because they're working a different spectrum. In this case, the spectrum could also be the Z coordinate, so how far something is in the background or not. So this is a very nice picture of Mount Dobrach in winter. And there you can see that I am mapping this square image on the side of a cube. So that's the whole idea. So you look up the UV coordinate in the X and Y of the picture. So the process of wrapping a 2D image around the 3D mesh is actually something that is called UV mapping. And that's the hard part. So that is something where my knowledge, my practical knowledge, my theoretical knowledge is kind of always extending, but my practical knowledge will not extend in this direction because UV mapping is something I really, really hate. I tried it several times. So I'm sticking to very common mappings or something where I don't have to do it. So what you basically do is you wrap a 2D image around the 3D mesh like wrapping a present. And in case of cubes, you can use it something like that. So you have M and N, and then you say you want to have this on one side, this on one side, and so on. And you unwrap your 3D mesh. It's also called unwrapping, the process. And then you get a picture which gives you the sides. That's the whole idea. Yeah, so that is one thing. So this, for instance, would be the NASA Earth image. And there's a clip from last year where I said, and as this image shows, the Earth is flat. No, it's actually not. I'm not a flat earther. But what we can actually do is, and I prepared that here on my wonderful Blender installation here. So this would be a UV sphere. We can zoom in. Hello, sphere. And what I basically did is I wanted to create a material that makes this like being Earth. So that would be the awesome part about it. So I go into the shading part because then I don't have to think about it. I've already opened this image. So you can basically download it from NASA. They're just flying about Earth and taking a picture down. Then you can see it's flat. No, it's not flat. Before somebody clips it again, it's not flat. They're just wrapping the image out to a 2D square image. And what I can do now is I will basically move this around a little bit. Oh, wait. So that's the output. And what I want to have the image here as color on this sphere. So I can add the image by adding image texture. Yes, that's the one. And that's also why I opened it already, because then it's in here and I don't have to search around. Wait, did I get it? I have to look at it here. Yes, now I got it. And I can connect those two here and voila, the Earth is displayed correctly. Let's see, it should not be displayed correctly, but it actually is. That's very nice. Because I didn't try it that way. What I did is actually, and I'll show you what I mean. Texture coordinates. So at some point we actually have to create texture coordinates, and if we just generate it automatically, then this does not work. As you can see, the polar caps are on the side, and yeah, well, I'm not sure. Can we even recognize anything in here? What is that? I'm not sure. Oh, that's the Caribbean here. The blue part here are the Caribbean. Is the Caribbean. So that might be, yeah, now I got it. Africa and Europe, Italy. I can see Italy. I can even smell the pizza here. And yeah, but at the end of the day, the wrapping is not what we want to have. And that's actually because we have to define the wrapping. And there are actually, for tubes, boxes, and spheres, there are predefined wrappings. And if we go to sphere wrapping, then everything works as intended. So we can actually see the polar cap. Move it around a little bit. Yeah. We can see the polar cap here. We can see Antarctica here. Finally, Africa shows off the right size. Northern and Southern America, Asia, Australia, Indonesia, Micronesia, everything's here. So, and it also looks quite okay-ish. We'll just switch it also to smooth rendering. Shade smooth, and here we are. Awesome, isn't it? We already have a picture of Earth, and then we can fool around with it and make it rotate or something like that. Yeah, so that would be the idea. Instead of painting Earth on top of everything, we can just assume that we have a picture and then wrap it the right way around the sphere, and then we can actually work with it. So that's the benefit of the whole thing. Yeah. However, as you could see, the sphere, box, and tube wrappings were already in there. UV wrapping as it is manually might be a little bit more complicated, and we'll take a look at that. Here you can see that would be planar. So we started out with planar, where the poles are at the end, then the cylindrical, where the Antarctica South Pole is far too big, and then the spherical mapping, which is the right one. Yeah. So I just showed it to you in Blender. You can of course do it in P5JS too. There's another example on that one too. In the I think. Hey, let's see if I did it. Introduction to texture Earth. Yeah, there's the example. So if you're going for the introduction to computer graphics sources, there is the P5JS file, and there you can actually texture the sphere with it, and then you have it inside P5JS too. Okay, where am I? Control. I have to control my streaming, so back to the streaming window. I need 17 monitors, obviously. That's kind of a problem. Yeah. So what we do is we map actually the outer points of the faces, which are typically triangles, or in this case quads, to the UV coordinates of the texture. So that's the whole idea. We say something like, this vertex here maps to this point here. This vertex here maps to this point here. This vertex here maps to this point here, this one to this one, and so on. And if we define that the right way, then we have this UV mapping, and the 3D framework knows what to do. If you do everything right, then these coordinates lead to a picture like that, a nicely done die. Actually, it's not nicely done, but anyway, a recognizable die. So this solves every problem, does it? Maybe not, maybe not. One thing is that, of course, if you zoom into everything, then you will see the pixels. So from this angle, it looks good. But if you zoom in, then you will see, oh my God, this totally looks like JPEG artifacts. And the textures are, if you zoom in, yeah, blocky. You see the compression artifacts, yeah, false colors, stuff like that. Yeah, you can of course use higher textures, but this all has to go into the RAM of in the random access memory of the GPU, which might be a little bit overwhelmed by it, especially if you put high resolution textures for each object you have in there. So what you typically do is you define the level of detail and then switch out the textures. That's a very common and rather novel approach, which is done in games, if you're wondering why this actually works. But at some point you're too far in. Wait, maybe I can show you with Blender here. We go in, oh no. Yeah, now it's starting to blur out, and that's actually what you can set up in the shading part. cubic. If we zoom in, wait, then this gets less and less detailed. It kind of blurs out based on the cubic, and if we want to have it pixelated, then we'll just use the nearest neighbor approximation of the color. So then we see the pixels. It was pre-installed with the linear thing, but you cannot make up the information. So you can make it a little bit blurred so that you don't see the pixels, but you can't make up the information. So here information is basically missing. That's the whole idea. Okay, so textures are always too small or always too big. So you have to find the sweet spot. That's a problem. So what you can do is you can repeat textures. So use small textures. This is actually, I think it's a photo of a cloth, something like that. So that would be a box of cloth. And funny enough, I didn't notice at the time taking it. There is one black dot in there, which appears here and here and here. So you can see this is mapped on each side of the cube. And you can repeat the textures, like having it repeated here. And there you can see some patterns. But yeah, well, you can zoom in more, of course. That's the part of it. So you have a small texture, you can zoom in, see more details. But if you zoom out, then everything gets mushy again. So that's the problem of that. Texture repeating strategies would be if you just wrap it or repeat it. Like if you have the R here, then we just repeat it once after the other. Then you can mirror it. So the R here gets mirrored to here, gets mirrored to here, down it's mirrored to that. Or you can basically clamp it. So you just repeat the last pixels. So that's also an option. So this is actually very bad because the checkerboard totally looks like this is transparent, but it's meant to be not transparent to show you that these are the last pixels that move on. And here with the mirroring, you have kind of not so good working thing. Of mirroring is much better than in this example. What else you can do is you can generate them procedurally. That's actually really fun because instead of using images, you can say, I want to have something like a cloud texture or Voronoi structures, and this can then lead to very interesting textures. In this case, it's Voronoi structure. Or in this case up here, it's Perlin noise. So what we can actually do is can remove this one and just add noise texture. Where is it? I want to have not sky. Voronoi. Yeah, that's what I wanted actually. I want to have the color here. Zoom out. I want to have the generated vector here, and then we have a Voronoi texture, which is made up by a noise function. Yeah. If you're wondering why Voronoi, because Voronoi actually gives you the option to make something like that, and that is the cool part. If you instead of just paint the different fields, but paint the distance to the edge, then you get something like scale or lizard height or crystalline structure. And yeah, that's actually the cool part. So you can zoom in and zoom out. Take a look at it and give it more detail and less detail. So that would be the texture based on procedural textures. So it just generates the image on the fly for those cases where you actually need it, where you can see it. So that's the cool part of it. They typically do that for wood or for crystalline structures with Wally noise and so on, or clouds with Perlin noise. Even water structures are used or created, or fluids are created with Pauling noise or simplex noise. So there's a lot of research went on into this. Yeah, image textures define the color of a pixel through a UV mapping, but you might be aware that images just carry numeric information. So it can be used to carry other information than color. So if we have image data at 0, 0, which is the lower left corner of the image, and it's 0, 255, and 0, then in RGB this would be the color of green. But we can also say this is a vector, a three-dimensional vector, and it's not giving color. And that's actually a cool part with the textures. So what we can do is we can, for instance, create bump maps. That's pretty cool. Oh, and now I realize I'm not sure if maybe I find GameBird on the fly. But what we can say is we take a grayscale image, and the image data instead of gives us not the color, but it gives us an offset along the normal of the point. So if the pixel is dark, then the point is higher up. If the pixel is light, the point is lower down, following the normal. And that would be called a bump map. And if you apply the bump map to this cube, then it looks like GameBird has been carved out here. If you blur GameBird a little bit, then you can see that the carving is not that hard. If we have sharp edges, then it's a very hard carving. The bump maps change the normal of a point in a little way, because the shading is the shading is changed. So it does not change the actual depth, but it changes the shading. And for that, you actually use a new normal vector, which is not the normal of the plane it's on. So if you remember shading and the interaction of light with a surface, the normal is taken into account. And with a bump map, you change basically the normal, and then you get a different shade for this pixel. So that's the whole idea. This is historically a fun slide because I wanted to give you an example for a bump map like this one here, but then I applied this as a displacement map, which we come later to, because what you can see is that here we have a rough edge, which you should not have for bump maps. This is not a bump map because a bump map will not show you this rough edge. In bump maps, the outline is basically the same, like here, and the surface only appears to be offset from the plane it is on. So that is the weird part. The silhouette of the model remains untouched, and what it's good for is shallow types, like brick walls from a distance, an orange or a golf ball or something like that. There is this online demo. Let's take a look at it. What I actually would need is drag and drop picture here. I need a GameBird. Wait, I can find GameBird. I should have multiple GameBirds on my computer. And here and here. Oh no, that's the concept. And no, that's not it. I'm not finding GameBird here. Now we got it. Media, GameBird. Ah, there. GameBird figure PNG. Yes. Oh no, that was not what I wanted. I'm sorry. I don't find GameBird. I don't know. Why don't I find GameBird? Let's at least take Ricardo's sticker here. So let's see. We have to move away the displacement, and then you see that this basically gives you it just gives you a kind of carved in version of GameBird. And And if we do displacement, then you see from the side that it's taken up here. Let's blur it a little bit here and reduce the level. Maybe it looks better then. No, not really. Yeah, but that's basically the idea. You give something that is obviously not a bump map, and let's take something like that. Oh no, not this one. And yeah, that would be the bump map basically. No, this is wait, there is the question, is it is displacement or normal? So if I'm hitting the displacement here, then you might see that it sticks out from the side. I'll just reload it because then I can show you here. So if I hit the displacement, then you'll see that it kind of pops out. If we don't have the displacement, it looks like it would pop out, but it actually does not. So that's the whole idea. Now we don't have the normal, no. Yeah, you should fool around with it because you can easily see the difference between displacement and bump mapping. That's the cool part of it. Well, I'm thinking of, oh, I'll make up something along the way when we do it with Blender, so not a problem. Okay, so this is an online tool to see what happens, so that's pretty cool. What you also have seen is this kind of map here. So this is actually a normal map. No, they are not the same. There's the question, have normal map and bump map, or are they the same? The normal map is actually computed from the bump map. That's the whole idea. So that's something we can see in Blender. I'll just have to prepare an example here. Don't save. And what I actually need is, that's why I changed the monitor. I need to find some textures, which I did not look up before. I have a lot of them, but I need to find appropriate ones. Oh, that's not it. Oh, I know where it should be. Painted wooden nightstand. Yes, that's it. I'll take this one. Oh, it sure doesn't work. Of course it doesn't work. Oh, no, it works. Okay. Let's see if I got the right example here. So there, for instance, you have a normal map. So this normal map actually gives you a kind of shading details. So we can remove it and we'll see the difference here. So the shading is different. We'll move it in and there should be an update at some point. It's already taken place and it should kind of look better. That's the whole idea. So removing the normal map from here, and everything looks more flat. If we add the normal map again, yeah, there you could, I hope you could see it. Removing it again, and wait, I have to get it, it's so small. Prepare, 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 and 3, 2, 1. Did you see it? So that's basically the whole idea of the normal map. So where is the normal map? Normal, here we are. It would not give me the normal map here. Where is it? Here we have it, normal, yes. And that's basically the normal map of the nightstand. And there you can actually also see, see, that's a good example. There you can also see how this is unwrapped. So this is the knob here. This is the knob here. Then we have the sides of the stand here. We have other small stuff, and this is all unwrapped. And depending on what you look at, this would be the normal map. This would be the color. And what is also there is the roughness. So how rough and how polished the stuff is. The bump map would be something like that. And we can actually fool around with it. No, maybe not with that. That might take a while. But what we can actually do is we can fool around with the bump map. Just have to find one. It's the only thing. Now that I'm missing out on Gamebird, maybe I should just download a picture like that. Doesn't like me at all, unfortunately. No, it doesn't like me. Okay, I definitely should have to prepare more for that one. But what you can actually do is you can load a bump map, so I can show you how it should work at least. Closing the 155 Blender images. So what you can do is, I can actually make up a bump map, of course. So I want to create a bump map. And what I can then do is I can create the normal out of this bump map here. And what I need is the input as a height. And there you can actually add an image, which I don't use now, but I will use a noise texture. Oh no, that's the wrong one. It's a sky texture. I need let's take a wave texture. Wave is good because it already brings us something like that. So yeah. So there you can actually see the bump map, and we can also put in the normal map here. Wait. So you can see that are the normals. Yeah. And what we can also do is we can do displacement, connecting it here. Let's see if that works out. Yeah, then it's displaced. This is different. Let's make it rings. And then you can see what I meant with wood textures are created with that. Okay, but that would be the bump map, creating a normal map. And there you can fool around with the distance and the strength and everything. And yeah, feeding the normal to the shader, and that's basically it. So the bump map is a grayscale image. And the normal map is a 3D image because it gives us 3 dimensions. The normals from each point, and the normal map can be created from the bump map. So that's the whole idea. Okay, moving on. Effectively, they do the same thing, but the bump maps can be drawn by hand. Normal maps are typically baked, but normal maps can carry more detailed information than bump maps, and both do not change the geometry and the shadow, of course, if you have shadow. Displacement maps, on the other hand, can be the same maps because you're displacing something along the normal, and they change the geometry. So the actual mesh points are modified. You might be able to see it if it's heavily displaced in the shadow too, depending on how good your shadow computation is. Not for real-time rastering, this might be a problem. because the shadows are also reduced in quality, but for ray tracing this should be visible actually. What else is there? Transparency maps, so grayscale images where image data gives the opacity of a point. They are used for making parts of models invisible, translucent, like dirty glass, thin leaves, or something like that. So you're tinting the stuff that is behind it. Yeah, and now for P5GS, I actually have it open. I just have to move to the right one here. And 07. Moving it here. Okay, so this is also a small example on texturing. So we have this wonderful image of Mount Dobrach and the broadcasting tower on top of it. And what we have here is we'll use position to basically tell where the triangles are. And we texture the triangles based on, the texture. So this works out of the box if you give the triangles in the right order. So that's the whole idea. And I can move it around. The texture image should be loaded. If you want to try it yourself, you have to upload the texture image, like here, upload file. So it's this one in this case. And then you can edit with load image, mountain JPEG. Of course, it's in WebGL mode. Texture mode would be image. And the rotate is for interactivity. And then you just define the triangles, fool around with it. And that already gives you the, oh no, the mapping is in here. So the triangle, wait, sorry. That's the point. That vertices are for mapping. Yes, you define the triangles, and at the same line you define which vertex of the triangle maps to which part of the image. So 0, 0 maps to the lower left point of the image. 640 and 0 is x 640 and 0 on one edge. So you see there are all four corners of the picture here, and they are mapping to each of the triangles. So that's the whole idea. If I change something like, 320. Then this would have an effect like, oh, I think I used the blue one. It does not like me at all. Yeah, I was just removing part of the image. So I was removing half of the image. So that's why it's not extremely up and down. So we can actually put in something like 120 here. Yeah, and now it messes it up completely. So now the UV mapping is messed up, and the one triangle, the upper right one, is having problems, or does not match the image as it matched perfectly before. Like, let's do it a little messed up, not completely messed up. Yeah, then you can see that here the mapping does not work. Looks like tearing. So that's the hard part actually. Okay, what else? You can give the UV coordinates in mode normal. Then they are given by 0 and 1. So 0 would be the whole length of the picture. The 0 is of course 0, but 1 would be the whole length of the image, regardless of the pixels, which is cool because then you can exchange the texture to a higher resolution or a lower resolution if you need it later. Otherwise, you have to change the code. That's the problem. And X, Y, Z gives the vertex, and UV the UV mapping. So that's the whole idea. We can use that to spread it over 3 quads, for instance. Wait, that's actually a very nice demo, as far as I remember. Oh, it's spreading just over 2 quads now. Where the picture is like in a brochure. So that's basically the difference. So there you can see that this can be, of course, mapped to any mesh. Well, it gets more and more complicated. So that's the downside of it. Yeah, it's just different coordinates. And of course, we can use the texture from Earth to actually put it up on a sphere. Wait, where is the sphere thingy? Here. And then we have the Earth animation. Failed to fetch. Looks like there was a problem loading the image. Why would there be a problem loading the image? It's here. Image, load image. Maybe it's the wrong name. I'll just copy over the name and put it in here. No, it's the same name. Oh, that's kind of weird. That's kind of weird. It's always fun to fix stuff while doing it live. Let's see if I can fix it. Download the whole thing. And putting it somewhere. Totally unzipping it in the download folder. And then running. Oh, what did I do? Okay, and maybe this just works. That would be so awesome. Yeah, and it works. So what I basically did, I just opened it on Visual Studio Code, and then you can run it with live server, and then it connects to a server that is created, and we can actually look at it. Yeah, so that's the Earth animation from this source code. Okay, something else which is a little bit more complicated, but also huge fun. I don't know if you know four-sided die. I'll show you anyway. I'm just searching for, no, that's not the one. That's the one, like that one. Oh, it again does not want me to, so just a moment, I'll download it again. And extract it. And open it. And there is the sketch, like on the picture, and I'll open it with live server. And here we are. So that's the four-sided die. It's a, is it called? Yeah, tetraeder, so 4 sides, and each side has a number on it. It's not very nice to look at, but it's actually a fun project because you're using this texture. Don't show again, don't show again. You're using this texture to map it on And tabletop enthusiasts on the chat, yes, they would definitely know what a four-sided die would look like. Please bring your dice bag, pull out one, and yeah. So the mapping works the same. So as you can see, there's ACF, ACH, AFH, CFH. So what I basically did is I assigned letters to the corners, and then I thought of how to actually do that. So as you can see, point A here should always map to the same. Point A here should always map to the same texture coordinate. Point C here would always map to the same texture coordinate. So that's the one here. And there's F and H. Yeah. Kind of looks arbitrary. I think I thought about something when I did it, but this is now a few months ago. So I have no idea why I used A, C, F, and H. Okay, so next up, your exercise, what you should do is you should create a six-sided die in P5.js. It does not need to look like that. That's also an animation from Blender. So I followed the tutorial. Don't have to do something like that. But what you definitely should do, you should paint or download the texture and map it correctly to a cube. That's the whole idea. So all the instructions how to do that are in these slides. So that's basically already the same thing. A more easy way to begin with would be with the mountains and the different triangles. And if you're wondering what a texture should look like, let's go here. That's what a texture for a six-sided die actually should look like. I mean, maybe not the same color and everything, but you can have fun with something similar like that one. Okay, if you have any questions, please let me know. Otherwise, we're really fast with the textures today. That's the beauty of streaming. It's so not interactive that I'm so much faster. We'll meet in the lecture hall next week, and I had to cancel around the 14th of June, so that's just an administrative thing. Can we upload a texture and use it in P5.js? Yes, it always worked, so I hope it's just something that just occurred right now. Otherwise, there should be tutorial on Moodle on how to do that. If it doesn't work out for you, let me know, then we'll find another way how to do that. But as you could see, if you install Visual Studio Code, you can actually run it in a live server. So Visual Studio Code, wait, don't show again. Visual Studio Code is, I don't know, there's this anecdote that I never used it because there were two competing things, and then one was Atom made by GitHub and the other one was Visual Studio Code made by Microsoft, and I said, oh, I don't like Microsoft, I'm using GitHub's Atom, and then Microsoft bought GitHub. I mean, what on earth? Microsoft bought GitHub and they closed down on Atom. So now I'm down to use Visual Studio Code. It's not bad, but the problem is that most of my shortcuts don't work anymore and I'm not using it that often. Okay, and if you install Live Server, you can basically open it with Live Server, and then you can code in here with the Sketch.js and use any texture you want, and then run the index.html using Live Server. And if you leave it open, the Live Server, then you can just change something like whatever, background 20. Save it, and then it will automatically update here. So that's pretty cool actually. Or background, whatever. GB, red, green, blue, 0, 120, 255 or something like that. Yeah, and then we have blue background. Yes, blue earth and blue space. Okay, so that would be my suggestion. Visual Studio Code is anyway something like a Swiss Army knife, which Swiss Army knife is saying that you can use it for everything. If you don't know the phrase. Yeah, they can actually code JavaScript. It gives you a lot of a lot of help on that. And yeah, you can just start in P5.js, then download it, put it somewhere, open the folder with Visual Studio Code, then run a live server, and then you see what you get out of that. So if it doesn't work on the editor p5js.org, then you can use it that way. Okay, then thank you very much again for joining me today. I'll definitely upload the video at some point. Oh, I just closed the slides, but that's okay, I think. You can see the wonderful view down, where is that? Mörtal. I think that's Mörtal, yeah. Yeah, we'll meet in the lecture hall next week. And yeah, thanks for listening. Thanks for thanking me. Thanks for listening, and see you around. Bye.